Okay, welcome everyone to another class of electromagnetic field and wave. Today we will cover the topic that is called curl of a vector. সবাই কি স্ক্রিনটা দেখতে পাচ্ছেন এবং কথা ক্লিয়ারলি শুনতে পাচ্ছেন? একটু মাইক অন করে বলবেন।
জি স্যার।
আচ্ছা, ওকে, তাহলে এখানে আপনারা স্ক্রিনে দেখতে পাচ্ছেন the name of the topic is curl of a vector. So far we have covered two topics about these vectors. One topic was the gradient and another topic was the divergence. So today we will continue the topic of curl of a vector. So what is a curl of a vector, sir? Curl of a vector, if I tell you in the layman words or in easy words, the curl of a vector actually lets you know that how much rotation will happen to a certain vector field. Okay, like suppose there is a vector field something like this. Vector field, let me draw from the bottom. There is a vector field something like this, there is a vector field something like this, there is a vector field something like this, there is a vector field something like this. So if you have vector field in x and y direction, something like this kind of vector field, and suppose you are putting up a stick here, you have taken a stick here. Now what will happen? As you have taken a stick here, you see that in the upper portion the vector field is larger than the lower portion. Okay, because this is long lines, that means the value is higher. That means whenever suppose a water is flowing here, the upper portion of the water is flowing faster and with force, then the stick will start to rotate. Okay, the stick will start to rotate something like this, then something like this, isn't it? Or suppose you have a stick here and there is some vector field, one kind of vector field is going here and some vector field is going here, so the stick is bound to rotate. Okay, so this is what actually curl is. Curl actually gives you an idea that how much rotation will happen in a certain vector field. This is actually a curl of a vector field. So I have given this book, and I hope whenever you will listen to the recording, you will also open the book simultaneously at the same time. So here we can see the definition: the curl of a vector field A. Okay, the curl of a vector field A denoted by curl A, or এই যে আমরা একটা নাবলা সাইন ছিল, ঠিক আছে? So triangle sign ছিল, অনেক সময় ডেল্টা বলে, অনেকে নাবলা বলে, whatever you choose. So a nabla cross A is a vector whose magnitude is the maximum net circulation of A per unit area as the area tends to 0, and whose direction is the normal direction of the area when the area is oriented to make the net circulation maximum. So there are some heavy words here, but if I tell you in the simple words, the curl of a vector actually means that how much circulation, how much net circulation or net rotation that will happen in a vector field. That is what curl of a vector means. Now our primary goal or our primary target is to know the notations and to understand how to find the curl of a vector. So you can skip this derivations. Where you want to go, you want to come here. This is nabla cross A or curl of A. We know that the gradient was just nabla A, divergence was dot product, and curl is the cross product. Okay, cross product of A, nabla cross A, and this is the formula. Okay, so if you can't remember this formula, you can write like this. Okay, this is the cross product. I hope I have gone through the vector multiplication, vector cross multiplication numerous of times. I hope this will not be complicated to find out the value. Okay, so suppose whenever you choose AX, then these two terms will come. Whenever choose the AY, then these two terms will come. So the result will be like this. Okay, the result of this will be like this. So if you have trouble remembering this formula, then you can do it from the matrix. Okay, the matrix থেকেও এটা করতে পারবেন. সো এটা হলো আমার কার্ল। কার্লে মনে রাখবেন কার্ল ইজ অ্যাকচুয়ালি নাথিং বাট দ্য ক্রস প্রোডাক্ট অফ দ্য ভেক্টর এন্ড দ্য নাবলা। ওকে, এটা হলো আমার ব্যাপার। সো এটা হলো একটু মনে রাখবেন। এখন দেখেন যে এখানে যদি আমি একটা এক্সাম্পল নেই, আমি একটা আপনাদের খান একাডেমি ভিডিও একটা লিংক দিয়ে দিব, একটু দাঁড়ান। আচ্ছা, সবাই দেখেন যে আপনার স্ক্রিনে একটা ম্যাথ দেখতে পাইতেছেন যে এখানে there is a vector v is given something like this. Here I, j and z is nothing but ax, ay, az. This is the unit vector in the x direction, unit vector in the y direction, unit vector in the z direction. So whenever you want to find the curl of this vector, you can do something like this. আপনি এটার মতো করে এখানে যে অঙ্কটা আছে, you can practice from this. Okay, I will give the link of this in the chat section. Okay, I will also give it in the PLC. So practice from this math. By practicing from this, you will understand how this works. ঠিক আছে, I will not go to the mathematical example due to the shortage of time. ঠিক আছে, এই এক্সাম্পলটা you will try at home. The formula is that I have shown here. With this formula you can do this math. Here I, j, k is nothing but ax, ay, az. Okay, so I hope this ax means the x part of the x magnitude part of the vector, ay means the uh, y directional magnitude, az means is the z directional magnitude. Okay, so I hope this is fine. Okay, এখন আমরা চলে যাই অন্য বিষয়ে। প্র্যাকটিস দিস ওয়ান। ওকে, এই ম্যাথটা একটু প্র্যাকটিস করে ফেলো। আচ্ছা, প্রসিডিং। Okay, now we will see two theorems. Okay, two theorems we will try to understand and we will use it in different aspects. Okay, so এই দুইটা theorem একটু দেখেন। This everything is here. I am discussing from the Cheng's book. Okay, that book is given on the our VLC. First, we'll come through the divergence theorem. What is divergence theorem? Okay, we have already discussed about the divergence. Now we will discuss about the divergence theorem. What divergence theorem is actually is? The volume integral of the divergence of a vector field equals the total outward flux of the vector through the surface that bounds the volume. Okay, what does actually mean? Volume integral of the divergence of a vector field equals the total outward flux of the vector through the surface that bounds the volume. এটার মানেটা কি স্যার? আচ্ছা, চলুন দেখি মানেটা কি। Let's understand this theorem correctly. Suppose there is some surface like this. Okay, there is some volume surface, something like this. Okay, so what is the divergence? You know the divergence is the net outward flux, isn't it? It is the net outward flux. Okay, now what this theorem actually gives us is the volume, the total outward flux of the vector through the surface of that bounds the volume. এখানে যে the surface that is situated here, there is some outward flux. এখানে there is some outward flux in this whole structure. The outward flux is actually the volume integral of the divergence of the vector. Okay, because we already know this makes sense, right? Because the divergence of any vector field is actually the total net outward flux. Okay, net outward flux of that vector field if you combine a certain surface. So the এটা এখানে বলছে যে whenever you are enclosed a certain surface, the outward flux of the vector through the surface of that volume is actually equals to the volume integral of the field. Okay, so এখানে হলো the thing you have to remember or you understand that the divergence of that vector field along that volume is equal to the is equal to the total outward flux of the vector through the surface that bounds the volume. ঠিক আছে, যে ভলিউম যে সারফেসের যে ভলিউমটা ওটা নেট আউটওয়ার্ড ফ্লাক্স, ঠিক আছে। So this one is my divergence theorem. We will use it in some of the postulates that will come in front of us shortly. আচ্ছা, এটা গেল ডাইভারজেন্স থিওরেম। Now we'll go another important theorem. এগুলো একটু মনে রাখেন যে কোনটা কই থেকে পড়াইতেছি। That is my Stokes theorem. Okay, now we'll go to the another term which is my Stokes theorem. What is Stokes theorem? The divergence theorem was about the divergence. So the Stokes theorem will be about the curl. Okay, about the curl. So here we can see the surface integral of the curl of a vector field over an open surface is equal to the closed line integral of the vector along the contour bounding the surface. এখানে স্যার কথাটা কি বুঝাইছে একটু দেখেন। কন্ট্যুর জিনিসটা কি? Suppose this is your surface. The contour actually means the line of the surface. Okay, line of the surface. Okay, so the contour means actually the line of the surface. So whenever you see something like this actually means the line integral. Means we are taking the integration or integral across the line. So what they want to tell us here is the curl of the net curl or the net rotation of this surface, the net rotation. There is some vector field, right? There is some vector field inside. Okay, there is some vector field inside. The curl of this surface, okay, the curl of this surface or the net rotation of the surface is equal to the what? The surface integral of the curl of a vector over an open surface. Open surface is equal to the closed line integral of the vector. এখানে যে লাইন ইন্টিগ্রাল আছে, এই লাইন ইন্টিগ্রালের যে ভ্যালুটা পাবেন, এই যে লাইন ইন্টিগ্রালের যে ভ্যালুটা পাবেন, value you will get the closed line integral of the vector along the contour bounding the surface. So if you are having trouble understanding the main theorem or the intuition, then just remember this thing that the surface integral or the surface curl of the surface, okay, the curl of the surface is equal to the closed line integral of the vector along the contour bounding the surface. ঠিক আছে, মানে আপনি এই যে লাইন বরাবর যে ভ্যালুটা পাইতেছেন ইন্টিগ্রালের, দিস উইল বি ইকুয়াল টু দা আপনার যে টোটাল কার্লটা। ঠিক আছে, এটা হলো কথা যে এখানে আসলে এই যে ইন্টিগ্রেশন দিয়ে what does this integration means? This integration means that you are trying to find the curl in every point of the surface. আপনি এই যে এখানে ছোট্ট একটা সারফেস নিয়ে suppose in this small amount of surface you have find the curl. Now you are adding, by integrating, you are adding the curl in every point of the surface. That value is equal to the line integral of the vector. ঠিক আছে, line integral. So এখানে হলো the main thing I want to make you understand is the two lines. ঠিক আছে, দুইটা লাইন আমার আপনাদের একটু ভালো করে বুঝতে হবে। One is the divergence theorem. Okay, divergence theorem is the volume integral of the divergence of a vector field equals the total outward flux of the vector through the surface that bounds the volume. এটা হলো একটা জিনিস। আরেকটা হলো আপনার another one is Stokes theorem. Stokes theorem কি? Stokes theorem হলো this thing that the surface integral of the curl of a vector field over an open surface is equal to the closed line integral of the vector along the contour bounding the surface. ঠিক আছে, এটা হলো আমাদের মোটামুটি ভেক্টরের যে পার্টটা, ওইটা হলো মোটামুটি আমাদের শেষ হলো। ঠিক আছে, এই কয়েকটা জিনিস একটু ভেরি ইম্পর্টেন্ট। নাও we will jump to the chapter or we will jump to the topic that is static electric fields. Okay, we'll jump to the topic static electric fields. Now proceeding, suppose if you ask me that সবাইকে আমার কথা শুনতেছেন তো না, রাইট?
জি স্যার।
আচ্ছা, তাহলে দেখেন এখানে হলো আমরা যে স্ট্যাটিক ইলেকট্রিক ফিল্ড চ্যাপ্টারটা পড়বো, এখানে এই চ্যাপ্টারের মধ্যে দেখেন যে one of the very important topic in the which is স্থির তড়িতে যে পড়ছিলেন স্ট্যাটিক ইলেকট্রিক এ যে কুলম্বস ল, ঠিক আছে, এই যে কুলম্বস ল। Now we'll learn the different aspect of Coulomb's law and in different types. এই যে আমরা যেখানে ভেক্টরের যে সাইন গুলো পড়লাম, the signs we have used here, we'll use this signs in different type, in different aspects. So Coulomb's law can be written mathematically as F12 equals to A R12 K Q1 Q2 by R square. Normal, if you remember the Coulomb's law you have learned, what was the Coulomb's law? Coulomb's law was very simple. F equals to, you know, some of you write the constant K, some of you write the constant C, Q1 Q2 by D square. This was my Coulomb's law. It was proportional to charge and the inversely proportional to the distance between the unit charge. ঠিক আছে, এই যে inversely proportional, এই যে এখানে ডিসটেন্সটা ছিল। But the Coulomb's law, the force that is generated between two charges are actually vector. How vector? Because suppose there is 2 point charges, huh? So you want to know, find the value of the attraction force or the repulsion force. If the 2 unit charges are positive, that means the direction will be in the opposite of them. If the 2 charges are not same, different, that means an attraction will happen. So this thing is described here, where F12 is the vector force exerted by Q1 on Q2. AR12 is a unit vector in the direction from Q1 to Q2, and K is the proportionally constant depending on the median and the system of units. We know this 9 into 10 to the power minus 9, something like that. Note that if Q1 Q2 are of the same sign, both positive or both negative, F12 is positive. That means repulsive, isn't it? Because Q1 and Q2 both are positive. That means F1 has to be positive. That means the F12, but the vector force is repulsive. And if Q1 and Q2 are opposite signs, F12 is negative. That means that is attractive. Electrostatics can proceed from Coulomb's law to define electric field intensity E, electric scalar potential V, electric flux density D. কথা বুঝেন, electrostatics can proceed from Coulomb's law to define electric field intensity, তড়িৎ ক্ষেত্র তীব্রতা, electric field intensity E, electric scalar potential বা বিভব V, electric flux density D. Then lead to Gauss's law and the other relation. This approach has been accepted as logical, perhaps because it begins with an experimental law observed in a laboratory, not with some abstract postulates. ঠিক আছে, এটা হলো এক্সপেরিমেন্টাল, এই কারণে এটা কোনো মানে এক্সপেরিমেন্টালি পাইছে, এই কারণে এটা কোনো অরিজিন বা কোনো কিছু থেকে প্রমাণ করা যায় না। আচ্ছা, নাও এখানে I will explain some of the postulates. Just go with me, you will understand. Fundamental postulates of electrostatic in free space. We have understood the Coulomb's law, right? The Coulomb's law is F equals to A K Q1 Q2 by R square. Q1 Q2 is the charge of particle 1 and particle 2. R12 is the distance between charge 1 and charge 2, and AR12 is the direction. Okay, where in which the direction where you can understand where the force is acting. Q1 to Q2 or Q2 to Q1. Is it attraction force or it is a repulsion force? Now proceeding, fundamental postulates of electrostatics in free space. Here you can see that the formula, electric field intensity definition, the definition of electric field intensity. Electric field intensity is defined as force per unit charge that a very small stationary test charge experience when it is placed in a region where an electric field exists. ঠিক আছে, এখানে হলো দেখেন কি বলছে যে ইলেকট্রিক ফিল্ড ইন্টেন্সিটি ইজ ডিফাইন্ড as the force per unit charge. Force per unit charge means একক চার্জের উপর যে বলটা অনুভব করা হয় is defined as the force per unit charge that a very small stationary test charge experiences when it is placed in a region where an electric field exists. ঠিক আছে, এই কথাটার মানে কি? এই কথাটার মানে হলো যদি দেখেন suppose 10 coulomb of charge 10 coulomb of charge is experiencing 10 newton of force, then 1 coulomb of charge is experiencing what? 10 by 10. This term is known as my electric field. Okay, unit charge যে the amount of force that is facing. Okay, so এটা এখানে মিন করছে, and the unit you can write Newton per coulomb or volt per meter. Both you can write Newton per coulomb or volt per meter. The electric field intensity E is then proportional to and in the direction of the force F, because Q has no vector sign. U is the scalar product, so the direction of E will be as the direction of F. If F is measured in newtons, charge Q in coulombs, then E is the new newtons per coulomb, which is the same as volts per meter. The test charge Q, of course, cannot be zero in practice. As a matter of fact, it cannot be less than the charge of an electron. Q যদি zero হয়, এটা তো infinity হয়ে যাবে, zero হতে পারবে না. However, the finiteness of test charge would not make the measured it differ appreciably from this. আচ্ছা, এরপর হলো দেখেন যদি আপনি ফোর্সটা বের করতে চান, F equals to কি হবে? Q into E. This is the relation of electric field, stationary charge, and the force. An inverse relation of equation 3.2 is the force on a stationary charge Q in an electric field. ঠিক আছে? Now, these are the very important two fundamental postulates of electrostatics in free space. Specify the divergence and curl of E. ঠিক আছে, the two fundamental postulates of electrostatics in free space specify the divergence and curl of E. The divergence of electric intensity, okay, electric field intensity, the divergence of electric field intensity is just rho by epsilon naught. I will explain the rho in a bit. And the curl of an electric field intensity is zero. Sir, can you give me an understanding why the curl of an electric field intensity is zero? Yes, I can. Suppose what was curl in the early part of our class, we have understand that the curl is the net rotation, that how much rotation can happen to a stick. Now, electric field intensity means that this is a, suppose a constant magnitude in the direction. Now, if you put a stick here, okay, if you put a stick here, then as these all of them are in the same magnitude, the stick will not rotate. So as the stick will not rotate, stickটা এদিকে যাইতে থাকবে কিন্তু it will not rotate. As the stick is not rotating, the curl of an electric field is zero. এখানে এই কথাটাই বলছি। In equation 3.4, rho is the volume charge density of free charges. এখানে যে রোটা দেখছেন is the volume charge density of free charges, coulomb per meter cube, and epsilon naught is the permittivity of free space. ঠিক আছে, রো হলো চার্জ ডেনসিটি, মনে রাখবেন এটা হলো কুলম্ব পার মিটার কিউব। 1 মিটার কিউবে there how many charges are there in 1 meter cube. আজ এরপর হলো দেখেন ইকুয়েশন 3.5 assert the static electric fields are irrotational, যেটা আমি বললাম যে রোটেট করে না। Where 3.4 implies that a static electric field is not solenoidal unless ওইটা আপাতত লাগবে না। Now this, if you remember the nabla sign, these are in actually in the differential form. These two postulates are in the differential form. I want to find out these postulates in integral form. How can I find it, sir? By the two theorem I have discussed earlier. One is divergence theorem and one is Stokes theorem. Now what they do, they have taken volume integral in both sides. মানে কি স্যার, দাঁড়ান দেখাচ্ছি 2 মিনিট। Suppose this is nabla dot e equals to rho by epsilon naught. So that taken the volume integral in the both side. In the both side. Okay, they have taken the volume integral both sides. They've taken the volume integral in the both. At epsilon naught is constant, they've put it out. Now, if you remember, for divergence there is something called divergence theorem. Volume integral, there is something called divergence theorem. We have seen it, and that was what? That was divergence is the surface integral of that vector field. Isn't it? একটু আগে দেখছি divergence আমরা, ঠিক আছে? এটা আপনারা whenever you are hearing the recording to দেখে নিন। And here you can see, এখানে একটা মজার জিনিস হয়, দেখেন এই যে আপনার এখানে এই যে you are integrating this part. This is the charge density you are integrating with volume. Now charge density means key that what is the charge in unit volume. As you are integrating over the volume, that means you will get the total charge enclosed in that surface, which is Q. ঠিক আছে, এখানে এই কথাটাই করছে। In a view of divergence theorem, 3.6 becomes something like this. Rho dV has become Q. Okay, এটাই হয়ে গেছে, where Q is the total charge combined in volume V bounded by surfaces. ঠিক আছে, is the amount of charge that is stored in S. Equation 3.7 is also a form of Gauss's law, very infamous Gauss's law, which states that the total outward flux of the electric field intensity over any closed surface in free space is equal to the total charge enclosed in the surface divided by epsilon naught. আবারও পড়ি, the total outward flux of the electric field intensity, ঠিক আছে, এই যে এটা, the total outward flux of the electric field intensity over any closed surface in free space is equal to the total charge enclosed in the surface divided by epsilon naught. Gauss's law is one of the most important relations in electrostatics, and we'll discuss it in the future. Now comes the curl. Whenever there is curl, that means we'll introduce the Stokes theorem. So we know that as this is curl, we know from the Stokes theorem that the curl of the vector is equal to the line integral of that vector. So here comes the line integral. এই যে দেখেন, the line integral EDL equals will also be 0. ঠিক আছে, এটা হলো মানে এই যে this term is replaced with the Stokes theorem and replaced with this. ঠিক আছে, the line integral is performed over a closed contour. Closed contour means এই যে closed path আর কি, ঠিক আছে, closed path, এটাই contour বলে। Closed contour C bounding an arbitrary surface, hence C is itself arbitrary. So এটা এই জিনিসটা দিয়ে আসলে যে একটা লাইন বুঝে, মানে the algebraic sum of voltage drops around any closed circuit is 0, এগুলো আসলে এখান থেকে আসছে। ঠিক আছে, যে আপনারা কার্শফ কেভিএল পড়ছেন না, এটা এখান থেকে আসে। ঠিক আছে, এই যে the algebraic sum, এটা তো closed path বলতেছে, যেটাতে you are getting the closed path. So the electric intensity field or the algebraic sum of voltage drops around any closed circuit is 0, এটা হলো এখান থেকে আসে আর কি। So there are so many topics I've discussed today, but I am giving a finishing here, the ending here, that what we have achieved today, the postulates of electrostatics in free space. We'll use these relations over and over again. So remembering these relations is very important. First, we understand the differential form of electrostatic field intensity. Nabla dot E, Nabla cross C. This is the divergence. This is the curl. And here we see the integral form. Electric field intensity is dot product with the surface, and electric field intensity dot product with line. Okay, so with surface it comes Q by epsilon naught, and with line it becomes 0. So these postulates means the shikarjo, ঠিক আছে, the shikarjo বা শর্ত। So So we consider this postulate like the principle of conservation of charge to be representation of laws of nature. In the following section we shall derive Coulomb's law, মানে আমরা এগুলা থেকে আস্তে আস্তে Coulomb's law তে যাব। So thank you everyone for your patience, আজকের ক্লাস এখানেই শেষ হলো।